Navigating the complexities of classified locations within wastewater treatment and collection facilities requires consulting reliable sources and experts. Several avenues can provide valuable assistance. Firstly, consider government agencies such as the Environmental Protection Agency, or EPA. The EPA possesses extensive resources on wastewater treatment and collection systems. To access their expertise, contact your local regional EPA office. Secondly, state environmental agencies play a crucial role. These agencies regulate wastewater facilities within their jurisdiction and may have specific requirements for location classification. Consulting them ensures compliance with local regulations. Thirdly, explore industry associations like the Water Environment Federation, or WEF. WEF serves as a professional organization for wastewater treatment professionals. They offer a Find an Expert directory, enabling you to search for professionals specializing in specific areas within the wastewater field. Fourthly, the American Water Works Association, or AWA, is another valuable industry organization. They may provide resources or context related to wastewater facilities, offering additional support for your inquiries. Fifthly, consider consulting firms specializing in environmental or civil engineering. Environmental engineering firms specialize in wastewater treatment and collection systems and can offer expert advice on location classification. Civil engineering firms often have experience in designing and building wastewater facilities, making them valuable resources for addressing classification issues. Sixthly, tap into the expertise of academic institutions. Universities with environmental engineering programs often conduct research and possess in-depth knowledge of wastewater treatment, potentially offering guidance on classification matters. Community colleges with wastewater technology programs may have connections to local wastewater professionals who can assist with location classification. Seventhly, engage with wastewater facility operators. The operators of the wastewater facility you are interested in may possess valuable information or contacts to aid in location classification. Eighthly, local code enforcement officers may have jurisdiction over wastewater facilities. They can provide guidance on compliance with local codes, ensuring adherence to regulations. When dealing with electrical systems within wastewater treatment facilities, understanding hazardous locations is paramount. The National Electrical Code, or NEC, provides guidance on classifying these locations. Class 1 locations are those where flammable gases or vapors may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. These locations are further divided into divisions based on the likelihood of the presence of flammable substances. Division 1 signifies that flammable gases or vapors are likely to exist under normal operating conditions, frequently during repair or maintenance, or due to leakage. Division 2 indicates that flammable gases or vapors are not normally present but may exist accidentally. Class 2 locations involve combustible dust. Dust can be present in sufficient quantities to cause a fire or explosion hazard. Division 1 in Class 2 means dust is present in the air under normal operating conditions in sufficient quantities to produce explosive or ignitable mixtures, or where mechanical failure or abnormal operation of equipment might cause such explosive or ignitable mixtures to be produced, and might also provide a source of ignition through simultaneous failure of operating equipment, or where dust of an electrically conductive nature may be present. Division 2 in Class 2 means combustible dust is not normally suspended in the air in sufficient quantities to produce explosive or ignitable mixtures, and dust accumulations are normally sufficient to interfere with the normal operation of electrical equipment or other apparatus, but dust may be suspended in the air as a result of infrequent malfunctioning of handling or processing equipment. Class 3 locations involve ignitable fibers or materials that are not likely to be suspended in air in sufficient quantities to produce ignitable mixtures. These locations also have Division 1 and Division 2 classifications depending on the likelihood of the presence of ignitable fibers. Electrical equipment in these classified locations must be specifically designed and approved for the particular class and division to prevent ignition. This typically involves explosion-proof enclosures, intrinsically safe circuits, or other methods to contain or prevent sparks or heat from igniting the hazardous substance. For example, explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits limit the energy available to a level that is too low to cause ignition. Understanding the specific hazards present in a wastewater treatment facility is crucial for proper electrical design and installation. Consulting with qualified electrical engineers and adhering to the NEC guidelines are essential for ensuring safety and preventing explosions or fires. The NEC Article 500.5 provides information on area classification. The presence of hydrogen sulfide, or H2S, and methane, or CH4, are common concerns in wastewater treatment facilities. These gases are flammable and can create hazardous atmospheres. Proper ventilation, gas detection systems, and appropriate electrical equipment are necessary to mitigate these risks. Gas detectors can provide early warning of gas leaks or build-up, allowing for corrective action to be taken before a hazardous condition develops. Regular inspections and maintenance of electrical equipment are also essential for preventing malfunctions that could lead to ignition. Grounding and bonding are critical for preventing electrical shock hazards and minimizing the risk of ignition. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of the electrical system to create a low impedance path for fault current. Proper grounding and bonding can also help to reduce electromagnetic interference. Surge protection devices, or SPDs, can protect electrical equipment from voltage surges caused by lightning or other events. Surges can damage sensitive electronic equipment and create fire hazards. SPD diverts surge current to ground, protecting the equipment connected to the electrical system. In wastewater treatment facilities, motors are used to drive pumps, blowers, and other equipment. These motors must be properly selected and installed to ensure safe and reliable operation. Factors to consider when selecting motors include horsepower, voltage, enclosure type, and efficiency. Variable frequency drives, or VFDs, can be used to control the speed of motors, which can save energy and improve process control. VFD can also reduce mechanical stress on motors and driven equipment. Lighting is essential for providing adequate illumination in wastewater treatment facilities. Lighting fixtures must be selected and installed to meet the specific needs of the area. Factors to consider when selecting lighting fixtures include light output, color, temperature, energy efficiency, and enclosure type. In hazardous locations, explosion-proof lighting fixtures are required. Control panels house the electrical controls for various processes in the wastewater treatment facility. These panels must be designed and constructed to meet the applicable codes and standards. Factors to consider when designing control panels include component selection, wiring methods, and enclosure type. Human-machine interfaces, or HMIs, provide a user interface for monitoring and controlling the processes in the wastewater treatment facility. HMI can display process data, alarm conditions, and control settings. Programmable logic controllers, or PLCs, are used to automate the control of various processes in the wastewater treatment facility. PLC can be programmed to perform complex control functions based on inputs from sensors and other devices. Communication networks are used to connect the various electrical and control systems in the wastewater treatment facility. These networks allow data to be shared between devices, enabling remote monitoring and control. Fiber optic cables are often used in wastewater treatment facilities because they are immune to electrical interference. Electrical safety training is essential for all personnel who work on or around electrical equipment in wastewater treatment facilities. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment, or PPE. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch. Regular inspections and testing of electrical equipment are essential for identifying potential problems before they lead to equipment failure or safety hazards. Infrared thermography can be used to detect hot spots in electrical equipment, which can indicate loose connections or overloaded circuits. Insulation resistance testing can be used to assess the condition of electrical insulation. Coordination studies are performed to ensure that protective devices, such as circuit breakers and fuses, are properly coordinated to minimize the extent of an outage in the event of a fault. Arc flash studies are performed to determine the potential arc flash hazard at various locations in the electrical system. This information is used to select appropriate PPE and to develop safe work practices. Single line diagrams are used to represent the electrical system in a simplified form. These diagrams show the major components of the system, such as transformers, circuit breakers, and motors, and their interconnections. Short circuit studies are performed to determine the magnitude of the fault current that could flow in the event of a short circuit. This information is used to select appropriate protective devices and to ensure that the electrical system is adequately rated to withstand fault currents. Load flow studies are performed to determine the voltage and current levels throughout the electrical system under various operating conditions. This information is used to optimize the performance of the electrical system and to ensure that it is operating within its design limits. Harmonic analysis is performed to assess the impact of harmonic currents on the electrical system. Harmonic currents can cause overheating of equipment and can interfere with the operation of sensitive electronic equipment. Power quality monitoring is used to continuously monitor the voltage and current levels in the electrical system. This information can be used to identify potential problems and to optimize the performance of the electrical system. Energy audits are performed to identify opportunities to save energy in wastewater treatment facilities. These audits can identify areas where energy is being wasted and can recommend measures to reduce energy consumption. Renewable energy sources, such as solar and wind power, can be used to generate electricity for wastewater treatment facilities. This can reduce the facility's reliance on fossil fuels and can lower its operating costs. Energy storage systems, such as batteries, can be used to store energy generated from renewable sources or from the grid. This energy can then be used to power the facility during peak demand periods or during outages. Smart grid technologies can be used to improve the efficiency and reliability of the electrical system in wastewater treatment facilities. These technologies include advanced metering infrastructure, demand response programs, and distributed generation. Cybersecurity is an increasingly important consideration for electrical systems in wastewater treatment facilities. These systems are vulnerable to cyber attacks that could disrupt operations or damage equipment. Implementing robust cybersecurity measures is essential for protecting these systems from cyber threats. The North American Electric Reliability Corporation, or NERC, Critical Infrastructure Protection, or CIP, standards provide guidance on cybersecurity for critical infrastructure facilities, including wastewater treatment facilities. These standards cover topics such as access control, security monitoring, and incident response. Cloud computing can be used to store and process data from electrical systems and wastewater treatment facilities. This can reduce the cost of infrastructure and can improve the scalability and reliability of the systems. The Internet of Things, or IoT, is enabling new applications for electrical systems in wastewater treatment facilities. IoT devices can be used to monitor equipment, collect data, and control processes remotely. Big data analytics can be used to analyze the vast amounts of data generated by electrical systems in wastewater treatment facilities. This data can be used to identify trends, predict equipment failures, and optimize the performance of the systems. Artificial intelligence, or AI, can be used to automate the control of electrical systems in wastewater treatment facilities. AI algorithms can be trained to optimize the performance of the systems and to respond to changing conditions. Virtual reality, or VR, can be used to train personnel on the operation and maintenance of electrical equipment in wastewater treatment facilities. VR simulations can provide a safe and realistic training environment. Augmented reality, or AR, can be used to assist personnel with the operation and maintenance of electrical equipment in wastewater treatment facilities. AR applications can provide real-time information and guidance. Drones can be used to inspect electrical equipment in wastewater treatment facilities. Drones can access hard-to-reach areas and can provide high-resolution images and videos. Robotics can be used to perform tasks in hazardous environments in wastewater treatment facilities. Robots can be used to inspect equipment, clean tanks, and perform other tasks that would be dangerous for humans. Additive manufacturing, or 3D printing, can be used to create custom parts for electrical equipment in wastewater treatment facilities. This can reduce the cost and lead time for repairs. Nanotechnology can be used to improve the performance of electrical equipment in wastewater treatment facilities. Nanomaterials can be used to create more efficient solar cells, batteries, and other devices. Biotechnology can be used to develop new methods for treating wastewater. Bioreactors can be used to remove pollutants from wastewater using microorganisms. Electrochemical technologies can be used to remove pollutants from wastewater using electricity. These technologies can be used to remove heavy metals, organic compounds, and other pollutants. Membrane technologies can be used to separate pollutants from wastewater using membranes. These technologies include reverse osmosis, ultrafiltration, and nanofiltration. Advanced oxidation processes can be used to destroy pollutants in wastewater using strong oxidants. These processes include ozonation, ultraviolet radiation, and hydrogen peroxide. Sustainable wastewater treatment practices can reduce the environmental impact of wastewater treatment facilities. These practices include water reuse, energy recovery, and nutrient recovery. Water reuse involves treating wastewater to a level that is safe for non-potable uses, such as irrigation and industrial cooling. Energy recovery involves capturing the energy contained in wastewater and using it to generate electricity or heat. Nutrient recovery involves extracting nutrients such as nitrogen and phosphorus from wastewater and using them as fertilizer. Public outreach and education are essential for promoting sustainable wastewater treatment practices. These efforts can help to increase public awareness of the importance of wastewater treatment and to encourage the adoption of sustainable practices.